I'm going to take a few minutes to give you a quick preview of the Rotational Collisions lab that you've been assigned on Pivot Interactives. So this lab has 3 parts. This first part, you don't have to collect any data, you don't have to do any number crunching. I'm looking for, in this first question, when it asks what happens to the rotational inertia of the system, does it increase, does it decrease, or does it stay the same? And then in question 2, I'm just looking for you to make some observations from this video, and again, tell me increase, decrease, or stay the same. Part 2 is going to show you a little bit of a more complicated collision. There's going to be a marble that shoots out of a launcher, hits this block. Now the location is a measure of how far from the center of the block that marble hits. So the block has this white line. If I choose a different location and I click go, then that marble is going to line up differently with the block, hit in a different spot. And so I want to know if these locations affect whether linear momentum is conserved. And so you'll need to go back to our definition of momentum. You'll need to make a decision about what kind of measurements you need to make and decide, is the momentum conserved? And as a reminder, if you go up to the toolbar, you've got a horizontal ruler that you can drag around. You've got a vertical ruler. You've got a stopwatch. And when we're just talking about linear momentum, the angle is not going to be super useful, but you do have an angle measuring tool if you wanted to use it. I also have in the hint here the mass of both the marble and the block. Now I'm going to have you write your answer as a CER, and I link to a summary of what are those 3 pieces, but the C is going to be your answer or your claim. So when it says, does the location of the collision affect whether linear momentum is conserved, your claim is going to be yes, no, or can't tell. Your evidence is what you're using to support that claim, so it's the measurements you made. It might be helpful to make a graph. It's not required, but I went ahead and I gave you a grid and a graph in case, or a data table and graph in case you'd like to do that. If you choose not to use a graph as part of your evidence, you would just describe or insert a picture of whatever you're using instead. If you click this little button, you can upload a picture as part of your answer. And then the reasoning, the R, is where you put into words what your evidence says and how that fits with your claim. So you're going to use that to justify your answer for whether where this marble hits the block affects whether the linear momentum is conserved. So going back to that idea of momentum that we used earlier this year. And then in part 3, we're going to start paying attention to the angular velocity. So you're going to find a relationship between the distance between the point of impact and the center of the block. So that's how far from this white line does the marble hit the block, up or down. And then the angular velocity of the block. Now on some of these impacts, you might notice the block rotates side to side as well as vertically. We're only going to focus on that vertical rotation. So as the block spins around in that plane perpendicular to the screen, or parallel to the screen. So we're not going to worry about that vertical rotation of the block spinning on its long axis. Now I should mention this does have a can in here as well. I've found that while the can is certainly more dramatic and a lot of fun to watch, it's hard to get good measurements from, but it is kind of fun to watch the marble just blast through the can. But we're going to stick with collecting data from the block just because you're going to tend to get cleaner numbers. So there's the quick overview of what you're going to be doing in this lab. You're going to post the graph you make for the relationship between the distance between the point of impact and the center of mass of the block, and then that block's final angular velocity. That's going to get posted in a forum, as is your CER. And as always, as questions come up, let me know and I'll be happy to help.